Section 4.2, modeling linear functions. All right, so we're going to deal with linear functions and their model. So we're going to talk about some lines of fit and lines of best fits when we write some equations of lines. I'm going to show you how to find a line of fit based on calculating that slope by hand, and then I'm going to show you how to use the calculator to do the line of best fit. So there's the key words that are involved in this section. So draw myself a little coordinate plane, mostly first quadrant area, and I'm just copying that so I can use it again. And if you've got some ordered pairs that are given to you, some data, they could be plotted on a coordinate plane. So just put some dots and kind of try to follow that pattern that I'm getting there, that they kind of have that trend. We can see that they all kind of follow that. That we could draw a line through those that gets pretty close to all of them. If I drew that line right there, that's fairly close to the middle of all of those points. And that's what we're going to be finding, that equation of that line out of that. So that y equals mx plus b, that slope-intercept form of an equation. Maybe even use the function notation f of x equals mx plus b. When the slope is greater than 0, that's a positive slope. Positive slopes always go up and to the right. Okay? It's always a checking point when we're looking at this. Positive slopes, positive correlation goes with that. Positive slope when we're dealing with linear stuff. I'm going to draw another coordinate plane and put some points on that follow a different pattern. Just putting some random points, but they follow a certain pattern. We can see that those follow the trend of the line that goes this direction. That would be f of x equals mx plus b, where m is less than 0. It has a negative slope falling from the left to the right. It goes down from left to right. Negative slope, negative correlation, those go together. Okay, so if you hear negative slope or negative correlation, that's where that's going together. Another scenario of things that could happen would be if we had set of ordered pairs and we plotted them on a coordinate plane and they did something like that. It's almost a flat line there, and it follows that trend that it's a line looking like this. Well, that is the case of it's linear because it makes a straight line, and then it has the same equation as a linear equation. The only difference is this one has a slope of 0. The slope is 0, it's flat, horizontal. Last scenario that we're going to draw a little sketch of, and then we're going to actually do some work with some data, is when it's a non-linear scenario, and that's where you've got points that might follow some sort of pattern, but they don't follow a straight line pattern, but they follow some other kind of pattern. We can see that these points here follow some sort of pattern, but it's not a straight line. That's what we're going to go to in section 4.3. It seems to follow a quadratic shape, but it's a pattern, but it's non-linear. So first section 4.2 is going to be about linear things, and when we get to 4.3, we're going to kind of jump to quadratic things. So dealing with that. All right, so let's talk about the actual writing of the equation. So I'm going to get a table here. Call this example A, and I'm just going to put some x values and some y values. 3, 5, 7, 9, 11, 13. Those are my x values. The y values that go with them, 0, 2, 3, 6, 9, and 11. Okay. If I were to take these points and plot them on the coordinate plane, like draw my coordinate plane and then on a piece of graph paper and plot them. You would see that they follow the pattern of a line, of an equation of a line. What we can find here is a line of fit. That's what we're going to do first, and then I'm going to show you how to find a line of best fit. You can see the difference in the two. Okay, a line of fit means you plot these points, and I want to show you with the graphing calculator how you can get it to plot the points for you so that you can see what's going on. So with the graphing calculator, I'm going to hit the stat button, which is the one highlighted in right there. It's kind of hard to see. That's red right on my screen, but it's the stat button. It's right here beside the circle. Okay, and before we all start, just so all of our calculators are in the right place, I'm going to hit number 5 and hit enter. That will correct any issues with the lists in your calculator. We shouldn't have to do that again. So that should set everybody's up to be the same. Okay, now we're going to hit stat. We're going to go to edit and edit. And we should be able to get to this place where we would put those lists in. In list 1, we're going to put the X values. In list 2, we're going to put the Y value that goes with them. So the X values are 3, 5, 7, 9, 11, and 13. And then over here in list 2, I'm just going to press the right arrow key to get over there. I'm going to put the Y values, and I'm going to be careful to make sure that I put the right Y value with the right X value because we're dealing with ordered pairs, so it matters. 3, 9, oops, nope, 6 goes first, and then a 9, and then an 11. Okay. Check your order pairs, make sure they're the ones from the table, 3, 0, 5, 2, 7, 3, 9, 6, 11, 9, and 13, 11. So make sure you've got your order pairs in there together, that you don't have an extra X value or an extra Y value because that'll cause us problems. The next thing to do is we're going to get it to plot these on a coordinate plane. So to do that, you hit second and then Y equals, and it should take you to this menu. It's the stat plot menu where you can get it to draw a histogram or a scatter plot's what we're doing, or you can get it to do a line graph. And the calculator can do a lot of things. We want a scatter plot, so I'm going to hit enter on number 1, and it's going to ask me, do I want to turn that on? Yes, I do. And then the type, the first option should be a scatter plot. That's what everybody's first option is. So we're going to leave it on that. This is a line graph, so it just connects the dots of the line. This is a histogram. That's a box and whisker plot. And that's a modified box and whisker. That's a box and whisker, and that's a step graph. We hardly ever use that. Your X list should be L1. Your Y list should be L2. Just should be that way unless somebody's went in and done something or you've changed it. If it is not listed that way, the way to get L1 would be second and the number 1. And the way to get L2 for your Y list would be second and then the number 2. If you, for some reason, put your X or Y list in the wrong list, you put it in L3 or something like that, you can change it here and not have to retype the values if for some reason you did that. Okay. What mark you use really doesn't matter. I usually just leave it on the first one. It doesn't matter what mark you let the calculator put. It just changes that. Since I've got the color one, you've got a choice on what color you pick. I'm going to leave it blue. And then I'm going to hit graph. And I should see some of these ordered pairs. I don't see all of them. I see 1, 2, 3, 4 of them. I have more than that in my table. So I need to see the rest of them to make sure it follows the pattern of the line. So to do that, I hit zoom and then the number 9. Zoom 9 gets you it'll fit your window to the list that you used for a scatter plot. We see these points. It looks like it follows the pattern of the line pretty close. All right. What we could do is, looking at that, think, okay, which two could I put together and it get pretty close to all of the points? So if we're going to find a line of fit, that's what we would do. And if I did that, if I picked the point 5, 2, and 9, 6 on my table. If I pick those two and connected those with a line on my graph, it gets pretty close to all of them. May not be perfect, but it gets real close. So that's the two that I'm going to use to get my line of fit. So the first thing you need to find when you find a line of fit is find the slope. And remember the slope formula, y2 minus y1 over x2 minus x1. So we're using these two ordered pairs so that we all get the same line of fit. Okay, and I would just plug in those values. 6 minus 2 over 9 minus 5. Be 4 over 4, which is 1. So the slope of my line of fit using those two ordered pairs is 1. Okay. 1x plus b. I need to find out what b is. So I'm going to use one of these same ordered pairs, plug in for x and y, and get b. I'm going to use 5 too because it's smaller numbers. So I'm going to have 2 is equal to 1 times 5 plus b. So that'd be 2 is equal to 5 plus b. And then I would subtract 5. And that's negative 3 equals b. So my equation for the line of fit is f of x equals 1x minus 3. That's the line of fit. That's one line of fit means you do it by hand. Okay? Line of fit means do it by hand. Line of best fit is easier. Line of best fit is using the graphing calculator to help you. Okay? We've already done the tedious work for finding line of best fit. We put all these into a list, list 1 and list 2. We graphed it with a scatter plot. And now all we need to do is tell our calculator to give me the equation for the line of best fit. What the line of best fit does is it finds the least squares method of how far you are away from each plotted point and minimizes that. Does a lot of calculations to get there. So we're just going to let the calculator tell us what the line of best fit is. So to do that, you hit the stat button again. But we've already put our data in, and we don't have to go to edit. We're going to go over to calc. Stat, press the right arrow key to get to the calc menu. And we're doing a linear regression. So option 4 is going to give us a linear regression line that's of the form we want, ax plus b, the slope-intercept form. A is the slope, b is the y-intercept. Okay, so we're going to choose option 4. Option 8 is also a linear regression. It's just in a different form. As long as you know the one in front of x is the slope, it doesn't matter which one you pick there. I always just pick 4 because it's the first one. Okay, so I'm going to choose number 4. And again, if you've got the latest operating system, if you've got a color one, they definitely have the latest one. It's going to ask for X list and Y list, list 1, list 2. A frequency list, that should be blank. And then you can store the regression equation. I don't ever do that because it takes too many button pushes to get there. It's easier for me to just write it down and then put it in if I need it. So I'm not going to do that. We just want to go down to calculate. If you're using one and it doesn't come up with this menu system, it's actually easier because it defaults to L1 and L2, which is the ones you'll always use anyway. Okay, so I'm going to hit calculate. And it tells me that the slope of the line of best fit is 1.12857, a bunch of stuff there. And the y-intercept is negative 3.8619 and some stuff after that. We did pretty good by picking those 2 points that we did, and we got close. This is closer, okay? So what we will do, our line of best fit, we're going to round that. Let's go 2 decimal places for each position. So 1.13 for the slope plus, or excuse me, it's a negative, so we're going to do minus 3.86. I want to show you on the graphing calculator the difference in those two lines. For y1, I'm going to graph 1x minus 3. And I want to see, that's how close that gets. It's pretty close. Y2, I'm going to go down here. I'm going to graph 1.13x minus 3.86. Not much difference in those, but it does get a little closer to these points up here. And, veers off of these two a little bit. Doesn't really get any closer there, but it gets closer to these 2 points up here, which is minimizing the space between them out of that. So there was not a whole lot of difference in our line of fit and line of best fit for that particular set of ordered pairs, but that's what we're finding. We're finding a line of best fit that's done by hand. Line of best fit is done with the calculator. Line of fit is done with the hand. Okay, by picking 2 ordered pairs. Let's do another one of those just to get the practice. Here's our table. -2, -1, 0, 1, 2, 7, 6, 3, 2, 0. I'm going to find the equation of a line of fit. And then I want to find the line of best fit, both. So the first thing I'm going to do is put those into L1 and L2 in my calculator. So I'm going to hit calculator, stat, edit, and I've got these other lists in here. I want to get rid of those. So I'm going to press the up arrow until the L1 is highlighted and then hit clear and enter, and it'll empty that whole list. And I'm going to put the X values in there, -2, -1, 0, 1, 2. L2, go up to the top till L2 is highlighted, hit clear, hit enter, and then put the Y values that go with each X value. 7, 6, 3, 2, and 0. Because I've already set up my scatter plot with the settings that I did earlier, second Y equals, all that's already done. I don't have to do that again. I'm just showing you that it's already done. You don't have to go back and redo that. The next thing I want to do is look at the graph so that I can pick 2 ordered pairs to go with. So let me turn off these or clear out these equations that I graphed earlier. I can't see my ordered pairs. How do I get it to fit the set of ordered pairs that I've put in? Zoom 9, good job. Now I can see them all. You can see that follows pretty close to the line. Okay. Now I need to pick 2 ordered pairs to find the equation of fit, line of fit. So we can pick this one, the first one and the last one. That would get pretty close. The second one and the fourth one, that gets kind of close. I think the first and the last does pretty good. If we pick this one here and then that one down there, on the ordered pairs, that would be this one and this one. We use those to find our equation for a line of fit. I think we'll get pretty close. So let's do that. So the first thing, if I'm going to find a line of fit, that's an equation done by hand, what's the first thing that I need to do? Find the slope. 7 minus 0 over -2 minus 2. It should be -7 over 4. Does it make sense that that has a negative slope? Because we look at the points, we look at that graph, they fall from left to right. So it makes sense it's got a negative slope. So there's a checking spot for you to make sure that you're, kind of in the right ballpark. The next thing to do, plug that in for the slope and then find the y-intercept. So use one of the ordered pairs that you use to get the slope to find the y-intercept. I'm going to pick 2, 0. That's an easy one to do. So y is 0, negative 7 over 4 times 2 plus b. Well, that's going to be 0 equals negative 7 over 2 plus b. I would add 7 over 2 to both sides. And there's b. It's positive 7 over 2. So my line of fit is this function, f of x equals negative 7 over 4x plus 7 over 2. That's my line of fit. I want to see how close that is to my line of best fit. So to find the line of best fit, go to the calculator, hit stat, go over to calc, select number 4, go down there, tell it, work that thing out. Negative 1.8, positive 3.6. F of x is negative 1.8x plus 3.6. If we had these in decimal form, that would be negative 1.75x plus 3.5. My line of fit, my line of best fit is pretty darn close. They're really close to each other. So that means I did pretty good picking my 2 ordered pairs for my line of fit because I got pretty close to the line of best fit. Again, those are hardly ever going to be the same equation. Will you ever find the line of fit and the line of best fit? On quiz or test, I'll tell you which 2 ordered pairs to use to find the line of fit. If I'm asking you to do it by hand, I'll tell you which 2 ordered pairs. That way, we're all finding the same line. Okay? Because it's kind of subjective which one you think's the best fitting when you sit there and kind of eyeball it. But everybody should always find the same line of best fit. Calculator, everybody's calculator should calculate that the same way. Okay? That's the first section. All right. Section 4.3. Quadratics. Quadratic functions. We'll deal with a few different forms of quadratics as we deal with stuff here. We're going to start with standard form. Standard form for a quadratic function is f of x equals ax squared plus bx plus c. A quadratic function graphs in this shape. Those are parabolas, or what they're called. It's a U shape. Not a hard V, but it's soft and round here on the bottom and the top. So it can be either of those, either up or down. There are some that are sideways, but they're not functions, so they don't fit into this section. So if you've ever seen the sideways parabolas, they exist, but we're talking about functions here, so that rules those out. All right. With standard form, one of the first things that we need to decide is which direction is our graph going to open, and that's done by how A looks. If A is greater than 0, what kind of number is it? Positive. If that number in front of x squared is positive, then it's going to open up. The vertex will be a minimum. Okay, we're going to talk about vertex in just a second. Vertex is this point here. The first one here is an example of one that has a positive A value. It opens up. The vertex is a minimum because it's the lowest point on the graph. Okay. If A is negative or less than 0, it's going to open down, and the vertex will be a maximum. Know that based on what A is and nothing else. Nothing else decides that. A is the only thing that decides that. No matter what form we're dealing with, we're going to deal with standard form, intercept form, and vertex form. A is in each one of those forms, and it does the same thing no matter which form we're dealing with. So that same rule applies throughout anything you're dealing with quadratics. You may hear me call that the leading coefficient, which means the number in front of the highest power of x. That same thing. A leading coefficient, all the same. Okay. All right. The domain of a quadratic is from negative infinity to positive infinity. Range is dependent or depends on A and the vertex. So we can't really say that the range is always this way. The domain, you can say the domain is always from negative infinity to positive. If it's quadratic, it's going to be that. All right. Let's get a little bit of formula stuff out of the way here. One of the things we're going to find is an axis of symmetry. And the equation for the axis of symmetry is found from standard form by doing negative b divided by 2a. Okay. Always going to be negative b divided by 2a from that standard form, if you're dealing with standard form. If you're dealing with one of the other forms, we're going to talk about how to deal with that. Okay. Axis of symmetry means it's going to be this imaginary line that cuts up through, right through the middle of the graph. If I were to fold those parabolas right on that line, they would match up side to side. That's the symmetry idea. So we're going to find the equation of the axis of symmetry. X equals negative b over 2a if we're in standard form. From that, so that's the first thing. Second thing will be the vertex. The vertex of a quadratic is an ordered pair. The x value of that ordered pair is exactly the same as what you're finding for it, for the axis of symmetry. Those always match. Always. Okay? The y value for that vertex, you're going to find by plugging that number into the equation and working it out. F of negative b over 2a means take whatever negative b over 2a is, plug it into the problem and work it out. You get the y value for the vertex. Okay? So vertex is an ordered pair, so maybe it helps to put x and y underneath it, that you know that's what that is. Okay. From there, the third thing we're going to find are the intercepts. Start with the easy one, the y-intercept. Y-intercept, f of 0. You're going to find plug 0 in for x, and that's going to get you the y-intercept. The y-intercept, if you're in standard form, always turns into this ordered pair, 0, c. X value is 0 if it's a y-intercept. The y value for the y-intercept, if you're in standard form, is always c. Standard form is the only one that you can pull the y-intercept off of quickly and easily like that. The others, you got to do some work for. Okay. The more difficult intercepts to find are the x-intercepts. And this is where solving quadratics comes in. Okay. When you're finding x-intercepts, we're going to set the equation equal to 0. Okay. Set the whole thing equal to 0. And then you've got options about how you can solve those. One option is factoring, which works sometimes. So factoring is an option for solving. We're going to look at this and an example or two and see if we can get somewhere with that. Another option would be quadratic formula. Quadratic formula is always going to work, no matter what. Factoring is a good option if you recognize the numbers fast. If you don't recognize the numbers fast, just go straight to quadratic formula. Quadratic formula works all the time. This is quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c, and then all of that divided by 2 times a. This part that's underneath the square root, it has a special name. It's called the discriminant. The discriminant discriminates what kind of answers you're going to have. Okay? If the discriminant, b squared minus 4ac, if it's less than 0, what that means is that you have no x-intercepts. Those answers are complex numbers. Remember taking the square root of a negative, pull that I out of there, that's where that's coming from. So the discriminant can tell us whether or not we even have x-intercepts. If the discriminant is less than 0, meaning it's negative, then we're going to not have any x-intercepts. We're going to have two complex solutions to that, which means it does not cross the x-axis. Okay? If b squared minus 4ac is equal to 0, we're going to have one x-intercept. It will be at the vertex. That's what happens. The vertex will be our only x-intercept. If that b squared minus 4ac is greater than 0, meaning it's a positive number, we're going to have two x-intercepts. So we're going to look at this and look at the graph of it on our calculator and see what's going on. Okay. All right. So let's look at an example of all this stuff. So I'll reiterate all these formulas as we do this example. F of x equals x squared plus 7x plus 12. There is an example of quadratic in the standard form. I have my students in my Algebra 1 classes make a list. You have to tell me what A, B, and C are, so that if you screw up the quadratic formula, you didn't have A, B, and C right, that's why. So I make them do that first. So what's A? 1, B, and C, 12. Okay, so I always just do that out of habit, and it's kind of served me well over the years. So that might be something good for you to do. Now, because A is 1, we know that the graph of this thing opens which direction? Up. It's positive. So it's going to open up like this, which means that our vertex is going to be a what? Minimum. Okay, so we know those things going before we even do any work, just by looking at that number in front. Sometimes that's all we need. When we get to the word problems in the next section, that's important to know those things. Okay, that's where we're headed. Okay. All right, so let's find the first thing. Let's find the axis of symmetry. I'm going to abbreviate that. Axis of symmetry. All right. Negative b over 2a is the formula. So negative b means change the sign of whatever b is. So we have a positive 7 as b. So we're going to have a negative 7 over 2 times a, when a is positive 1. And we're going to work that out. So that's negative 7 over 2. So our axis of symmetry is x equals negative 7 over 2. Or, since this one is nice and terminates, a decimal might be. Understand that it could be written as either of those. Okay. So there's our axis of symmetry. Because we know the axis of symmetry, we know that what part of the vertex is also -7/2.